Some of the comments in that last video got me thinking about electromagnetic interference. So I tried just detaching the spindle from the mount there, so there's no electrical connection back to the Arduino, because it's sitting on wood, so there shouldn't be any electrical connection. And I'll also disconnect the laptop power, and I found that I could still make the problem happen even in this situation. So right at the moment we're okay, and then when I turn the motor up for a bit, it's not as bad, so we still have it working now. But somewhere along the way we'll lose it. Okay, now I've lost it. Actually, yeah, it's interesting that I've done this 3 times. This is the 3rd time now, and each time it's tended to be more around the lower throttle. I'm just calling this throttle. But it was around about quarter throttle or a little bit below quarter throttle that it loses the connection most often. So now I've completely lost all communication with the Arduino, and there's no electrical connection. So I guess what that means is that it is electromagnetic interference coming from this, because this is 100 volts here. This motor is not a 24 volt motor or anything. For some reason it's 100 volts. So there's some pretty high voltage coming through here, and you know, it's just sort of sitting there by the Arduino. So I guess this wire needs to be shielded, eh? Or the Arduino needs to be shielded, or the USB cable needs to be shielded better, or something. So the next thing I tried was to separate the power supply and the Arduino by distance. So I have the power supply down there under the bench, and the cable's coming up over here. So it's a good distance away, probably about almost a meter away from the Arduino, which is over there on its own. And that made no difference whatsoever. Well, after playing around with this a bit more, I've finally come up with a configuration that works and that it doesn't lose communication with the Arduino, but it's obviously not ideal because the motor is over there. That works. It's not very useful, though, is it? Playing around with this some more, I decided to replace this rather long USB cable that was connecting the laptop and the Arduino. It's about 1.5 meters, I think. Pretty long. And I replaced that with a 30 centimeter one, which is definitely shielded because it's one of those cables that has a transparent, what do you call it? The plastic is transparent, so you can see that it's shielded. I don't know about this one. I think this one probably was shielded as well. Not sure. Anyway, and I'm not having any problems with that, although the motor is not connected. But it does let me at least run the motor, which is running now. So I can run them all at the same time. So hopefully this will still work when I reattach the motor. Reattach the spindle, and unfortunately, while it has improved a bit, it doesn't fail as often. It still fails. So that wasn't really a good answer either. I also tried making the cable from power supply to the spindle come from all the way over here, but that doesn't work either. So I hooked up my scope to the Arduino. This is the RX pin of the Arduino, and it's not doing much, but you can see there's a little bit of traffic on that pin every now and then. Like that. Now let's see what happens when we spin the motor up. Alright, so the motor is on very, very low speed there, and that all of a sudden looks a whole lot messier, doesn't it? This is about as low as the motor can go. It's a little bit faster, about quarter speed. Oh, and we have lost control of the Arduino, by the way. So here's what that looks like up close. It's a pretty nasty pulse of wow, it's even like up almost 2 volts in some cases. Look at that. 2 volts approximately every now and then. And those pulses are coming in at about every 60 microseconds. So that's probably more than enough to mess up the Arduino's communication lines. This is with the laptop disconnected from the mains. If I plug the laptop into the mains, it improves a little bit. Just a little bit. So I'm plugging the laptop in now. So it's just a tiny bit better when the laptop is connected to the power. Okay, now I have the motor dismounted from the frame. It's sitting on the wooden waste board, and you can just occasionally see a little bit of spikes on there, but not as bad as before. But then when I touch the aluminium clamp to the base of the CNC machine, like the main plate, we see those spikes come back immediately. So I'm just going to touch the clamp on here. Look at that. So perhaps this, so I lifted it off now. Hopefully you can see that there. But those spikes come right back when I'm touching this on here. So I guess this this whole assembly is acting in a way like an antenna to increase the effect that those voltage spikes are having on the surrounding area. Kind of unfortunate, isn't it? Alright, now I have disconnected the stepper motors from the Arduino. So there's no physical connection whatsoever between the CNC machine and the Arduino, and we still see these spikes. So I did this to make sure that it is an actual sort of a radio frequency or a RF electromagnetic interference rather than something that's travelling along the stepper wires. So I guess it was actually travelling along the stepper wires a little bit because it's not as bad. Oh, hold on a minute. We're not touching the aluminium there. Hold on a second. Let me see if I can make it worse by touching the motor to the CNC base. Yes, it gets a bit worse. It's not as bad as it was before though, still. Or is it? No, it's not quite as bad. But definitely touching this to the CNC base does make it worse. Alright, now I have connected the chassis of the spindle to the frame of the power supply unit. So the spindle is now grounded. Doesn't seem to have made a whole lot of difference, but I think it might be a little bit better. So at the moment it's just sitting on the wood there, spinning. And if I put the spindle onto the main plate now, it actually doesn't change things much. So I think this is a bit of an improvement. So now it's connected to the main plate, and it looks to me like nothing's really changed, whereas before this would have made it worse. Now it's disconnected from the main plate. So it's a step in the right direction at least. Yeah, there's a few nasty big spikes still. Now I've connected all the stepper motors back up to the Arduino, and it gets slightly worse, although I think it's still a bit better than it was before. So that's full throttle, and yeah, it's definitely better than it was. So let's see if I can move the motors around with the spindle running. Motors are running okay now, stepper motors that is. Yes. Try full speed. Oh yeah. Okay, I'll just play around with this for a bit, but I lost it. No, still not good enough. Damn it. So, looks like we might be having some success now. I just connected one of the ground pins of the Arduino to the case of the PSU. Yep, like about 10 people told me in the comments. Finally I did it. And This awful noise we hear over here is the spindle spinning at full speed, while it is, at least so far, not having any problems moving the steppers. And I'm running the test program. It's only a couple of minutes into it, but at this point it looks like it's not having any trouble. So basically just ground all the grounds to mains earth, or whatever you want to call it, the earth that comes out of the power socket. And I think the problem that I had before was that I did not, when I connected my Arduino to this, I connected my Arduino to, oh, it stopped. Motherfucker. It's just stopped in the middle of the, you bastard. Okay, I take that back. It's still not fixed. Anyway, what I was going to say there before I got interrupted was that the problem in my other video where I had the fireworks was because I had connected the Arduino ground to this ground there, which is not actually a ground, it's actually 100 volts above the case, or, well, now the case is connected to earth, so it's 100 volts above earth, which is not very good. So that's why I had that problem, and now I don't have it when I'm connecting the Arduino ground to, well, to the case, which is to earth now instead of to that ground. So just looking at the signals on the RX pin of the Arduino again with this situation, and when I turn the motor on, what happens? Oh, this is not good. See that? Why is that happening? It's not supposed to be moving. It's holding it steady, so it was definitely doing that under power. That wasn't just the vibrations from the spindle causing that. I'm just doing another test run, but this time with the motor, the spindle only at about 1/3 speed. And I think this one will go okay. I mean, I can't really see any spikes at all on the scope. So hopefully this is going to finish without any issues. Yeah. So I guess the next step would be to try, what do you reckon, shield that cable that comes down from the motor to the power supply? Like put some, electromagnetic shielding around that cable. Is that what I should do next, perhaps? Okay, I'm going to try a cut, very, very simple cut into balsa. Yeah, I know, it's a bit of a cop-out, but I wanted to see it cut something. So it has to be something soft because I can't turn the spindle up very much. Oh, it's not square. Seems like it might be a little bit off. And it didn't go all the way through either. Let's see if we can go all the way through this time. Okay, there we go. Here it is, my part. If only everything was as easy to cut as balsa, huh? Wouldn't that be nice? So I think that's about all I can really do at the moment, given that I can't turn the spindle up to full speed. I suppose I could try some plywood maybe? I'm just trying some plywood now. This is 2.2mm plywood that came with one of those RC plane kits that I got. I think it came with the Eagle, this one. So let's see how this works. Well, you can see I've already done one in the background, but it didn't quite cut through, so I think this one will cut through. Oops, I think it moved a bit there. That might be my fault. Oh, this is going to be tiring. Ooh, looks good. I didn't quite get through some of these ones. Not bad, I suppose. You can see this bit is not made for this. It's sort of bunching up on there. The little stringy bits. You're supposed to have a flute type for cutting this stuff, I think. Yeah, that's right. Oh well, at least I know I can cut plywood, even with this problem with the motor electronics, the spindle, you know, voltage spikes and everything. If I go slow, I can at least cut something. So this was the bare minimum I was hoping to be able to achieve, to cut plywood. Seems comfortable enough at this speed too. So that was with a slightly faster spindle speed. I was just trying to see if it would stop again. Seems to be okay. It wasn't full speed, it was more like about almost half speed. And I doubled the speed, the feed rate, horizontal feed rate, and for balsa at least that seems to be perfectly fine. I just realized that I didn't change the zero position between the last cut that I did before this one, which was 2.2mm plywood, and now I'm doing 3.4mm cut, so that's 1.2mm difference, and the difference has gone into the wasteboard, so there's actually a 1.2mm cut all around the wasteboard, and I didn't even notice any difference. It didn't seem to have any trouble with it, even though it was going twice as fast as it was before. It didn't sound any different. So that's a good sign, isn't it? I mean, it didn't have any problem cutting through the MDF. So maybe it's a little bit more capable than I'm giving it credit for at the moment. Oops, no, I think I spoke too soon there. If I line up the back edge where my fingers are there perfectly, this edge at the front is about 0.5 mm off. So I think it was actually losing some steps while it was doing that. Whereas if I compare it to these other ones that I cut at the slower feed rate that were not cutting into the wasteboard at the same time, they match up perfectly with the plywood. Now, I haven't broken anything yet today, so I thought I might have a go at this little piece of aluminium. It's 1.4 millimeters thick, that piece that I'm going to try and cut. I'm going to go very, very conservatively here. Just make a tiny little cut in 3 steps down and see what happens. Ooh, there's already touching that. See how fast we can go. That's not good, eh? I can hear it sort of vibrating. I think it's already touching. Oh well, see what happens. Okay. I was told that would happen. Oh well. So those bits are not going to handle that, I guess. Okay, I've slowed the feed rate down to about half of what it was then, and let's see how this goes. Ooh! Yeah, it's bending that bit, I think. Quite a bit. Almost made it! So here's the result of that. It didn't even really cut it, it just sort of mulched it up a bit. Just sort of shoved the little bits of aluminium around inside the hole and that was it. So no wonder it broke. It wasn't a... I don't think it's what you're supposed to be using for this. It's a little burr, I think they're called. So it's not a flute thing, it was a... Oh, well, there it goes. Just looking at these again, I don't think these were cut properly either. It seems like this narrow piece here on each side is a different width. So on this one on the left it looks like it's a little bit narrower, and when I measure it with the calipers it's a fraction of a millimetre narrower too. This one the same. So this bit looks a bit narrower than this bit. And this one pretty much the same thing, I think. Oh no, that doesn't look too bad. Yeah, but anyway, I don't think it's actually doing a perfect job yet. Maybe need some stronger motors or something, even for this. But, well, that was kind of fun. Managed to get something cut, so I'm happy for today at least. But still a long way to go.